In this lesson, we're going to bring together everything we've learned about exponents and powers and see how we can simplify more complicated expressions using them. So here's a summary to begin with of all the different exponent laws that we've covered over the past few lessons. Multiplication, division, power of power are all from grade 9. The product of a power, that's where we basically use a distributive law. If we got a multiplication inside brackets and quotient of a power, same idea, we're distributing that exponent across each part. The zero exponent, all you need to know is that anything to the exponent 0 equals 1, but remember that the exponent only affects what it's immediately beside. So if there's a minus sign in front of something, it's not going to become a positive unless that minus sign's inside brackets. Negative exponents we saw mean 1 over the same power with a positive exponent, and rational exponents we saw make us take the root of the base use the denominator to take that root of the base, and then if there's a number on top other than 1, we'll raise it to that numerator number. So let's put all these things together. Simplify, express each answer with positive exponents. So on the first one, I look at that and I see they've got similar bases and they're multiplied, so I can add these exponents together. And so I get x to the negative 7. But this one says to simplify with positive exponents. So that means when I get to the end, I don't do anything about the negative exponents until I get to the end because they might sort themselves out. But if they don't, as they haven't in this case, once I get to the end, I need to write it as a fraction, 1 over x to the 7. That's all it means by saying that. In this one, there's a bit of order of operations going on. I have to do the power of a power first. That's y to the negative 3 times negative 3. And I get y to the negative 3 times y to the positive 9. Then I'll add those together, which becomes y to the positive 6. So in this case, I didn't need to do anything with a negative exponent because they all went away before I was done. For this one, whenever we've got powers inside a fraction, do the numerator, simplify that as much as you can first, and then the denominator, simplify that. And then the last step, you can do a division between the two. So on the top, I'm going to end up with c to the negative 15 when I do powers of powers. On the bottom, it's very easy to overlook this c that's here in the middle. That is actually another term that we have to deal with. That would be the same as a c to the exponent 1. So do be careful to not overlook those little ones that can sneak past us. So if I do negative 4 plus 1 plus negative 20, I end up with c to the negative 23. And then I would do c to the negative 15 minus negative 23 for that division. And that would be the same as c to the negative 15 plus 23, which becomes c to the 8. So again, there's no need in this case to do anything with the negative exponents because they did sort themselves out. Simplify each expression, and again, leave the answers with positive exponents. So they're getting a bit more complicated in this example because we're having different types of bases. In this last example, my bases were all the same. In the A part, they were all x, B part y, C part c. But in example 2, I got x's and y's and combined together. So we're going to have to be a bit more careful. So this first one is a power of a product. So that's one of those ones where we have to treat each part as being raised to the exponent 2 here. So x becomes x to the 2, and y to the negative 1 becomes y to the negative 2 when I multiply those together. And I'm also going to treat this like it's, sorry, I'm not sure why my iPad keeps adding extra lines on me today, but I'm going to treat each of those like they're raised to the exponent 5 as well. So I'm going to multiply those together. X to the negative 3 times 5 becomes x to the negative 15. y to the 4, all raised to the exponent 5, becomes y to the 20. So I take care of that 2 and that 5 outside the brackets first. Those are the power parts. Now I'm going to multiply. And just like when I multiply terms, as we've seen before, I'm going to multiply the same types of terms together. So I'll multiply the x's times the x's. So x to the 2 times x to the negative 15 means I add those exponents together. When I multiply y to the negative 2 times y to the 20, I'm going to add those exponents together and I'm going to get y to the 18. Now, I would be done except for the part where I have to have positive exponents. That means I have to deal with this negative 13. The way I'm going to do it this time is I'll rewrite it as x to the 13 times y to the 18, still like that. And then, of course, I could simplify it, make it look a little nicer just by bringing this y to the 18 up top. So I'd have y to the 18 over x to the 13. And that's the answer I definitely want. But I would normally, rather than having this in-between step here, I wouldn't normally do this in-between step here. From experience, you're going to get to recognize that if you've got multiple terms, like you've got here in this line, you can make it into a fraction, leave anything with positive exponents on the top of the fraction, and drop anything with negative exponents to the bottom while changing the exponent to a positive, just like we did here. So I leave the y to the 18 on top, put x to the 13 on the bottom, making it a positive 13, and that's the quickest way to do it. So that might come up again in another example. Definitely come up in the homework. All right, so the first one, the first thing I want to do for part B is I've got this negative 1. So the very first thing I think I would do is I'd just flip this upside down and write it as xy to the 2. Oops, that 2 should be on the outside though, shouldn't it? X to the 3, y to the 4, to the negative 2, and I'm going to put that over top of 2x cubed all squared. Because that negative 1, again, just if it's already a fraction, as we've got here, we'll flip things upside down. Now, if I simplify, again, it's like distributive law. I'm going to apply this 2 to each part here. So I've got x to the 2, y to the 2. I'm going to apply this negative 2 to each part here. So I've got x to the negative 6, y to the negative 8. On the bottom, I'm going to apply this negative 2 to the 2 and to the x, and so I've got 2 to the 2, which is going to be 4, x to the 6. If I start simplifying my x's on the top, when I multiply those together, I've got x to the negative 4. If I do the y's together, I've got y to the negative 8. On the bottom, I've got 4, 2 squared is 4, x to the 6. Now, again, I can think of x to the negative 4 as 1 over x to the positive 4. I can think of y to the negative 8 as 1 over y to the 8, same thing. Instead of rewriting it that way, a shortcut is I can just take this x to the negative 4, move it to the bottom, move this to the bottom as well, and just drop the negative signs. That's a shortcut based on math. And so what I'd get is, well, if I take everything away from the top, I'm not left with 0, I'm left with 1, because really what I'm doing is dividing. And I'd have, if I move that x to the negative 4 to the bottom, I've got x to the positive 4. I've got 4 still on the bottom. I've got x to the 6 still on the bottom. I've got y to the positive 8 because I moved that to the bottom. So when I switch things from numerator to denominator, I can do that. I just need to change the sign of the exponent. And it works going the opposite way too. If I was to go from denominator to numerator, I could just switch it from the bottom to the top and change the sign of the exponent. So then I can just combine my like term type things. So I've got x to the 4 and x to the 6. I can multiply those together and I'll get x to the 10. I'll put the 4 first as a coefficient. I'll write x to the 10 next because I'll go in alphabetical order, and then I'll have y to the 8. So this would be my final answer for this one. Simplify each simplify, express each answer again with positive exponents. So again, the same things going on here. Just more practice, right? So for this part, I'm going to multiply the exponents together. 9 times a third equals 9/3 or 3. Negative 20 times 1/5 equals negative 20 over 5, or that reduces to negative 4. Multiplying those together means I add the exponents. Negative 3 plus negative 4, sorry, positive 3 plus negative 4 is negative 1. And I have to write it, now them down to a single term, write it with positive exponents. So I'll just write y to the negative 1 as y, 1 over y to the 1, or simply 1 over y. This one, because it's written as a radical, if I want to use the exponent laws, I should write it back in that format. So I would rewrite this as 256 x to the 24, so what was under the square root. I would rewrite that as an exponent of 1/8, because the exponent of 1/8 means take the 8th root, right? And so I could do that, and then I'll be able to use exponent laws on it. Likewise, on the bottom, I can do this 4096 x to the 24, and raise that to the exponent 1/6, because it was the 6th root. Then I can use my exponent laws. I can apply the 1/8 to the 256 and to the x to the 24. Remember, it's the power of a product, so I have to apply it to each part. So I'm going to take the 8th root of 256, which I'm assuming is going to be 2, but just to show it in this case. 8th root 256 is 2. Right, so the 8th root of 256 is 2. And then if I do x to the 24 times 1/8, that's 24 over 8, so that just reduces to 3. So x to the 3. If I take the 6th root of 4096, that equals 4. And again, if I raise x to the 24 to 1/6, I'll multiply those powers. 24 over 6 is just 4, so I end up with x to the 4 is what that reduces to. Then I can simplify. 2 goes into itself once and into 4 2 times. X cubed, the 3 x's on the top cancel out with 3 of the x's on the bottom, just leaving a single x. And so I've got 1 over 2x once everything's reduced. And I could leave it like that. Okay, so these are a few of the examples. I can't do examples of everything because there's so many variations. But you always want to go back to the exponent laws, and there is an order of operations, which is the same order of operations you know. It's not a new thing, but you have to apply the order of operations, bed mass, in all cases to make sure that you don't do something out of order, of course, which would get you the wrong answer.